let's just welcome straight to the show from University of Otago, the Department of Marine Science, Dr. Bridie Allan. Bridie, good morning to you.
Hello, thanks for having me.
Oh, look, thanks for joining us, and it's fantastic to see you early on in the show, and we can just rip into this conversation that we're all wanting to talk about. And obviously, you are a marine biologist. You work in the marine area of study. The reason we're talking about this is the story that came out yesterday. Here's a little bit of a highlight of it from One News, talking about microplastics being found in human blood. But I suspect, and if we think about the species that are animal kingdom, there's going to be a lot of research that you've done that could be transposable over into some conclusions potentially with what's going to happen in humans. And this is for me as well. Look, let me just set this up by saying this. I'll show you. This is our thumbnail for this morning's show. And this is the imagery I put on for microplastics because this is the imagery that came up, when I Googled it. Now, I'm assuming that this is not what we're talking about because this this massive piece of blue plastic down here, that ain't ever getting into anyone's bloodstream, obviously. And that made me think maybe I don't understand exactly what microplastics are. So maybe just to start off with, to help us all understand a bit more, you could just let us know what we're talking about when we're talking about microplastics.
Yeah, absolutely. It's a really good point, I think, that you've got that image up there, because that really is what springs to mind when most people think about microplastics.
Yeah.
But microplastics, as you saw in the image, are actually quite large. Anywhere up to 5 millimeters is the general sort of cutoff, that defines a microplastic.
Wow.
Now, in the study that came out yesterday, which was really interesting and probably quite shocking, hence a lot of media attention, is probably really referring to something called nanoplastics, which are anything from 1 nanometer up to 0.001 microns. So that's the next category that's below microplastics. And as you mentioned, those are things that are the similar size to nutrients or molecules or even red blood cells, hence their ability to pass through tissues in the body.
Right. So nanoplastics would be a more accurate way of thinking about potentially what this research is talking about. Your research, I'm assuming you also see nanoplastics within the marine world as well. Do you see nanoplastics in fish blood and other marine life within their blood system as well?
Yeah, I haven't looked at that specifically, but the way I like to think about it is macroplastics turn into microplastics turn into nanoplastics through time. It's kind of like this iterative process of degradation. We typically work with microplastics because they're a lot easier to work with experimentally because they are larger. Nanoplastics are extremely difficult to work with. And so I'm not aware of too many studies that in a similar research field of my own, but there are studies out there that do show that they do pass into the blood system of fish, for example, or into the brains of fish, and have various impacts, but it's always at nanoplastic size.
I'm interested in your research and what you've found, what the effects that microplastics actually have on animals.
Yeah, it's interesting. We've done quite a lot of work on marine fish from tropical ecosystems, so coral reef fish, to fish here in New Zealand, kingfish, or even small triple fins, which are common here in Otago. And what we've found sort of consistently across all those different systems is that exposure to microplastics causes something called oxidative stress, which is a situation that arises when an animal ingests something toxic or is exposed to some sort of environmental stressor. And it seems really common across various fish species, and that comes at a real cost to energetics as well as to fitness because it can lead to things like cell death or tissue damage. We've also seen changes in behavior, but mostly we're seeing consistent physiological changes rather than consistent changes in behavior.
So when, Bridie, when you talk about those changes, you're saying they're not consistent? Is it like behavior as in, I don't know, movement of the fish or like their eating habits or, Yeah,
there's a lot of things you can measure with behavior, right? But often underpinning behavior is a physiological change first. So that's usually what happens that then might lead the fish to behave in a different way. And typical behaviors that we look at are things like the way they respond to predators. So look at their escape performance, but also the way in which they interact with their habitat as well. And we have shown with coral reef fish that they will suffer higher mortality rates after they've been exposed to plastics. We're not sure of the exact mechanism of that, but it could be due to something called false satiation. When you consume plastic particles, you feel like you're full, but you've got no nutritional value from those. And so your behavior changes in such a way that you just try and feed more and more frequently and increase your conspicuousness to predators, really, which likely leads to the increase in predation rates.
It's
Sorry.
absolutely terrifying considering how much marine animals we consume and the effect that that would have on us over a lifetime. And we're only really scratching the surface of this now. That's terrifying.
Yeah, well, there's a lot of studies globally that have shown that microplastics are making their way into our food sources. So fish that we buy, for example. But a lot of it's looking at what's found in the gut of those fish. And we typically don't buy fish with the gut intact. But things like bivalves, organisms or anchovies or sardines, things that you consume whole with the gut intact, that's likely a path of us ingesting plastics as well. But it's really difficult to find out what the impacts are on humans just because of the difficulties in getting samples, which I think is why that study that was published yesterday was so interesting and got a lot of attention. So yeah, I think it'd be great if that study increased the replication, just to see how common that is across a larger sample size. I think that'd be pretty interesting.
There was, they surveyed, so it was in the Environment International Journal, they surveyed 22 people and found microplastics in the blood of 17. So I guess quite small. Now, Bridie, I know that you deal with marine animals, but can you start to sort of extrapolate and speculate on how you might see the changes you've identified in marine animals reproduced in humans? If we were just to make the assumption that there would be changes to humans, what sort of things might we see in behavior?
Yeah, it's interesting because we all, as scientists, you extrapolate a little bit, but you're warned against speculating, of course. And so it's difficult. Zebrafish research, of course, is designed as a sort of model organism that you can potentially translate those effects into a human model system. In terms of the work I do, I'm not sure I would see any gross changes in behavior in humans. But interestingly, and Sally Gore raised this in the media last night, that there's a lot of chemicals that are bound into plastics themselves. It's not necessarily the physical impact of ingesting those particles, but it's the chemicals that you find within them. So things like phthalates, which are plasticizers, which are used to increase longevity and the flexibility of the plastic itself. And they're really known as endocrine disruptors, particularly affecting things like reproductive hormones. And indeed, there was a study that came out of Taiwan some years ago about male workers working in a PVC factory, inhaling a lot of airborne microplastics or really nanoplastics. And they sort of correlated that with decreases in sperm motility and sperm activity through time, which would have obvious implications potentially on reproductive rates. And we see a little bit of impacts with plastics and plasticizers in our fish in terms of reproduction, but the jury's still out and we haven't really found anything that's entirely conclusive at this stage, but we are working on it.
I'm also wondering the real specifics of from how we get it in our blood. Because like I've always said, eating sardines is evil. I mean, we all can agree to that. So that's not going to be how it's getting in my blood. But are we getting them in our blood from our interactions with plastics, or we're eating things with it in their blood or in their system and it's passing through membranes into our blood? How's that all actually happening full stop?
Yeah, it's an interesting point, and it's probably a combination of both things, right? You have primary ingestion of plastics, which is when you will consume plastics yourself, and then secondary ingestion of plastics, which is when you consume something that's consumed plastics. And you see that a lot in the FIS literature in terms of is it primary ingestion or secondary ingestion? Right. And to be honest, for human consumers, it's probably a combination of both. I'm sure that Sally yesterday raised that we all have carpet in our house. It's often composed of nylon in part as well as wool. But we're all using plastic products all the time. And so, there's reports out there to suggest that, estimates that we might consume around a credit card of plastic every single year, most of that would just pass through us. It'll pass through our digestive tract and be released. What would probably happen during that time, or what may happen during that time, is that we might get leaching of chemicals that are within those plastics as well. And that's what causes damage to hormones and things like that, as I described earlier. But in terms of secondary ingestion of plastics, if you're consuming other organisms that have eaten plastic, it's really difficult to know, and it's extremely variable.
Right.
It's particularly in the marine environment, you might get a change in the prevailing wind conditions, for example, and that's going to bring a lot of plastic out of the pelagic environment. And so I think when you're thinking about plastic entering our food chain, it depends on a lot of different things. Waste management practices in the country, population size, but also oceanography plays a major part in that as well.
Bridie, what in your research, maybe giving you a chance to sort of maybe mention any non-microplastics research or things that you're interested in, specifically with New Zealand, right? Like, what do you see as maybe one of the main challenges to marine life in New Zealand in a general sense, and maybe some shortcomings around, I don't know, regulation or restrictions and that sort of thing?
Yeah, I think, the marine environment's facing multiple threats, right? There's global climate change, which is, of course, ocean acidification, ocean warming. That's a global stressor, but then overlaid on top of that are local stresses. And these local stresses can change depending on where you are. For example, in Otago, we have problems with sedimentation, but also things like invasive species, pollutants, oil pollution, plastic pollution, of course. But, if I was going to pick a stressor that I would be most concerned about in the marine environment in the future, it would certainly be global warming and increasing frequency of marine heat waves. And there's been a lot of chat in the media about the plastic issue sort of detracting away from the importance of people considering global warming and ocean acidification. But it's really just a suite of stresses that will all interact together. They're not acting individually, they're going to interact together and create effects that might be of greater magnitude than if the organisms are exposed to those stresses individually. So that would be the one that I would want to get some sort of control on. But global warming, how do we as consumers deal with that and change our processes?
I have a bit of a random question, but you've seen changes in behavior in marine life because of microplastics. Have any of those changes been positive? And I was thinking, and it's not the same thing, but I was thinking about toxoplasmosis. Plasmosis, I think that's what it is. And how that obviously, for some reason within behavior, reduces risk factor. And if you read some writings on it, it says things like promotes entrepreneurship. Obviously, that means the risk factor of someone has gone down. It's a strange way to say it, but apparently more entrepreneurs have toxoplasmosis than the general population, sort of thing. And whether that's positive or not, I don't know. But I'm just saying, is there anything that you've seen within this kind of terrible news of microplastics in the marine world that has ended up helping the behaviors within that marine world?
I can't think of any studies in the marine literature that have suggested some sort of benefit to plastic pollution. I guess, if we think about tiny organisms like microorganisms, anything that's, around 100 microns in size or smaller, all of this debris in the environment, this plastic debris, creates a unique sort of habitat for those sorts of organisms, transporting them around the world. And that's been sort of recognized as a new ecological niche called the plastosphere. I guess that's a benefit for those small organisms. But, it's a double-edged sword, right? It could also transport pathogenic organisms as well. So, I can't think of any real obvious benefits to plastic pollution.
I get it. Stupid question, but I wanted to ask it anyway.
No, it was interesting.
Anything else, George and Shelly?
I'm good. I just wanted to note before, that, sorry, stealing the screen from you, Pat, that there are these, that DuPont put, stuff in pretty much every person's bloodstream. They didn't inject it in there, but in terms of their sort of waste from their chemical processes, you can't find anyone in the world without PFAS in their bloodstream now, right? And so I think we have to, this is just a great example of how we need to, we need better protections, we need better accountability if we're going to, stop this from happening again with microplastics. So I just wanted to remind our viewers about DuPont and Forever Chemicals.
It is a bit crazy that one, because you think about having, like the people who are living their healthiest life, maybe they're catching and cooking all their own food and growing it, and even those people are going to be impacted by what's put into the environment, so no one can get away from it. Sorry, Chewy, you go, mate.
I was just saying, I remember there was a raft of products a few years ago, exfoliating microbeads in face care and body scrubs and all of that sort of stuff. And I just remember thinking, when I saw those, I was like, that doesn't sound like a good idea. We're just putting billions and billions of tiny little plastic beads into the water system. Not great.
Yeah, it's quite remarkable, really, what gets out into the consumer market. But luckily, a lot of countries have banned those products, and others are opting for voluntary phase outs. But, plastic, there's a reason why plastic's everywhere. It's such a great product. And it has been since, it was very first commercially developed in the early 1900s and 1940s. So, yeah, there's small things you can do as an individual to reduce your plastic intake. Not heating in plastic containers. It's a really simple fix. Those chemicals that are in those containers, they leach out at around 24 degrees. About half of the chemicals will leach out, and then it's relatively stable after that. And that's a big dose of, quite significant chemicals to take into your food source.
Hey, Bridie, thanks for joining us today. Really appreciate it.
No problem.
Really
Thanks for having me.
No,
yeah, thanks, Bridie.
Awesome. It was really interesting to get your take, and we appreciate you giving us some time. Dr. Bridie Allan from the Department of Marine Science at the University of Otago. I'm sure we'll talk to you again sometime.
Awesome. Thanks, guys.
See ya.